Hi, in this video I'm going to show you how to make a quick drilling program for flanges or something. This is just a tutorial so that you could get used to making your own tools and with any bolt pattern you have. So we're going to go with a new sketch. Select this bottom plane, create a circle on center, and we'll make it 10 inches diameter. Then we'll extrude it with a solid button, press extrude, and I like to go -2 inches because I like my Z on top, my Z0. Okay, so now we have some sort of a surface, a flange type surface. Now we can do another sketch on top of that. And we'll put a circle on center again, right about there. And we'll make it 875. And we will give it a dimension. Our circle is 10 inches. Let's put that at 4 inches out. So we'll take that and extrude that circle to make a cut. We'll select it. Then we'll scroll to the bottom and highlight the bottom surface, which tells it to cut all the way through our flange, 2 inches deep, and press OK. Now we have a hole. Doesn't look like a bolt pattern, so we'll go to create a pattern, circular pattern, and what we want to do is select faces from the object type. Select that face. It says one object selected. Now it's asking us to select an axis, and I'll select the outside face of this flange, and it automatically gives us 3. So let's say we want 8 holes. It'll automatically do it in full 360. Press OK. Now we have 8 holes. Now let's make that 10. If you want to edit that, just go right here to the bottom, double click your circular pattern, double click your quantity, type in 10, press OK. Now we have 10 holes. And for me, that flange is probably too thick. So let's make it 1.5 inches. And double click on our extrusion from the flange. Click the distance, minus 1.5. And the reason why I do that is because sometimes our end mills aren't long enough to go 2 inches deep. This is just an example, so. All right, so we have a flange with 10 holes. Now we'll take that, press design, go to manufacture. On the manufacturing page, we're in milling up here in the top left. We'll go to new setup. And I like to tell the machine where I'm at, where 0's at. So I'll click the orientation drop down, tell it my Z and tell it my X. I want this surface to be my Z and X is already going in the right direction. The origin point will be the center of the stock, which I'll change stock is going to be a fixed size cylinder, 10 inches, 1.5 inches long, on center, round to the nearest half inch. Doesn't need to be anything. Just make it 0. So our setup's correct. We're doing milling. Okay. Press OK. Now we have work coordinates set. Even though our little view cube is not showing the correct Z, our machine Z is correct for our part. So now I go to setup, right click setup, and I'll make the tools from scratch. Right click setup, new operation, drilling. Now it's going to ask us what kind of tool we want, and I'll go with a center drill. So I'll go to use the libraries and search, and I'll type in number 3, and anything with the number 3 in it will get pulled up in the filter, and I want a number 3 center drill. We didn't tell it what kind of material this is, so we'll pretend it's steel, high carbon steel, and we'll select the cutting data that came with Fusion, and that doesn't look bad. We don't need multi-axis. This is just a 3-axis part. And we'll select our hole faces. You can go in here and select each individual one, or you can press select same diameter, and Fusion will select them all, or should select them all. There you go. Your red is the entrance. It'll start here, and then green is your exit. This is for geometry. So now we selected same hole diameter. We don't need a containment boundary. We don't care about the model right now. Let's go to the heights. Retract height. I like to use the selection. So I'll select the top, which is Z0 in our case, and give it a 1-inch clearance. Retract, same thing, selection with the 1-inch clearance. Feed height. We're always taught to feed from 100 thousandths above this selected surface. Again, top height, it's going to be a selection. You can make this however you like it. I like to do the top selection or Z0. If I'm working on a surface that's below 0, like an inch below on in a pocket or something, by making the selections, it automatically creates the proper clearance height and retract height from that selection. If you need to clear tools or toe clamps or something, then you should just always select the top with the appropriate clearance. Bottom height is going to be from the top of the hole. Now we're just doing a center drill, and usually you can only go as deep as the diameter on the center drill. So we're going to go minus 0.187 for a number 3 center drill. And then next tab is cycle. We are drilling with a rapid out. And press OK. Now we have a drill cycle for center drill, and we can see what happens when we run the simulation. You can see the solid underneath the stock from the simulation. You can turn that off with the models, and there's nothing there. So you can press play and watch it center drill all your holes. All right, exit simulation. Let's turn the model back on. And from here, the easiest thing for me to do, and for anybody else, is just duplicate your tool. Right click, edit the new. Press this tool in the first tab, and let's go to user libraries and type in 7/8. And you'll get 7/8 drill at the bottom. Again, high carbon steel. Select. And this is 13 thousandths per revolution, which is kind of fast to me. If your machine can do it, that's great. I like about 4 thousandths per tooth, so 8 thousandths revolution. We'll go to the drilling tab, the cycle tab at the end, sorry. And we are doing deep drilling, full retract. Here, I always like to do with a big drill, a 125 peck. We don't need to change the heights because they've already been selected because we duplicated this process. We don't need to select the hole pattern because it's already duplicated from the previous one. Press OK. Now you have all your holes drilled, except this thing thinks that we're drilling a hole 125 deep. Right click, edit again. We'll change the height of the bottom. And what I like to do is just go to selection here, because sometimes you're drilling into a pocket. Select the bottom surface of our flange. And it doesn't look like it poked through. Select drill tip through bottom. And that will make the corner of the cutting edge of the drill through. If you change that to 0, the drill cutting edge will be right on the edge of the part, which kind of doesn't always happen properly. So I give it a -50. And that should go all the way through. Hit OK. Zoom out. And let's run a simulation of what we just made. We'll take off the solid again. Press play. Here's our center drill with a little holder. Here goes our drill pecking through. And that shows it takes 13 minutes. You don't have to wait that long. And for basic holes, that's it. But you always have to chamfer a hole. So why make your operators chamfer everything by hand? Let's go in here and make a contour, 2D contour. Select the tool. We'll go to user libraries and type in chamfer. And Fusion has some stuff that's already in there. Like, let's say this 425 thousandths 45-degree chamfer, which looks terrible, but we'll modify it. I'll select the tool again, right click on the tool and edit it. Just for notes, I'll change this to 500, 45-degree chamfer mill, and I'll change the diameters to 500, shaft diameter to 500, tip diameter. What I'm used to using is a 1/2" 45-degree chamfer mill with a point. It's probably got a 10 thousandths tip, but I always put 0. and that's what it ends up. So that's what I'm looking for. Cutting data, you can change it if you like here, or you can change it on your speed and feed in your process tab. For me, 5,000 is fine, 2,000 per tooth, fine. You end up at 39 inches per minute. Press accept, press select. Now what do you want to do here? We can at least chamfer one side of this flange. Now we'll select geometry, the top of that, all the way around this flange. Okay. How's our height? Retract height, selection, here, again, 1 inch. Retract, selection, 1 inch. Feed height, selection, top surface. Feed height is 100 thousandths. Top height, top of the part is here, 0. You don't need to make any offset. Bottom height, I like to leave it 0. Why? Because it's going to ask for a chamfer here at the bottom, and I want to tell it how big it is. You want to add wear so that there's a D offset in the program. And I want the chamfer to be 20 thousandths. Next one, we don't need to worry about linking. Safe distance, just leave it as defaults. 50,000 feet right in. I don't like this vertical lead in. I always delete it. And we don't need the ramp. Don't need to worry about the rest of this stuff. Press OK. And wait for our computer to process. This is a very old computer. And now you have toolpath, you can see. So we don't have to run through the whole simulation. We can just select that tool. Simulate with machine. And it'll give us the previous cuts. Our holes are already in there. And our chamfer comes in. And does it look like it did anything? Yes. 20,000 chamfer. At least your operators and machinists appreciate that from you. So we can exit simulation. There's our toolpath. Open up the model. So now we have center drill, and a chamfer. All right, so let's say we wanted to make those holes 1 inch. Let's go back to design and edit our hole diameter to be, let's not make them 1 inch, just make them 1 inch 0.62. So now either you have to have a drill big enough, let's say you're doing this in a VF2, which not have a lot of horsepower, or you want a better surface finish for a drilled hole, like a milled hole. What I end up doing is specializing the tools or standardizing the tools where we'll center drill with an undersized drill and use a 1/2 inch end mill to put the bolt pattern on size. So we'll go back to manufacture, and all of our processes are orange. We do want the same thing to happen, so we'll tell it to right click on setup and generate. So everything we did will generate, except our holes will be 875 because of the drill, but we'll chamfer a 1 inch 0.62 hole, and that looks terrible on a simulation because the chamfer tool only chamfered what it thought it should do. which looks terrible. So what we want to do is add another tool. So we'll take another contour, grab a tool, use your libraries, and we want a standardized 1/2" end mill, which is not showing up here. Let's go with 1/2". Okay. Here we go, 1/2" flat end mill. And scroll down to high carbon steel finishing. All right, so that tool is probably not sticking out long enough. So go to select tool, right click, edit 1/2" end mill. Go to cutter, and we want to stick that out 2 inches. There you go. Flute length is 1 inch, and so most of the time the flute length is like 1.25 inches. We know part of the shank will be rubbing, but it'll still look better than a drill. Press accept. Shoulder length must be larger than, we'll do the shoulder length 1.5. There you go. Accept. Following operations are using speeds and feeds preset has been edited. Yes, we just edited it. All right, so now we have enough stick out. Now we'll go to geometry, select everything that needs to be machined. And our heights are not set, so we'll do the same thing. Selecting the top surface. Feet height, 100 thousandths. Top height. Bottom height is going to be selection also. And I roll to the bottom of the part. Select the bottom surface. And I want the end mill to break through. So just like the drill, minus 50 thousandths. The difference is here, we're not going to take the full depth of end mill. We're going to helix in or spiral in. I'm going to highlight compensation while we're here. Put in wear so we have a D offset. We don't need roughing passes. We don't need multiple depths. We want to ramp in, which is the helix in. 2 degrees ramp clearance. I changed it to 50 thousandths. And then we will press OK. And you can zoom in and see a helix, which I hate that 3 radii that come in. I just hate the way it looks in the program. It's a lot of extra code that doesn't need to be there. So we'll take out this bottom one, change it to 0. Your operators will read the code better at least. So now you have a helix that goes in there. We'll take the model away to see the whole helix. Goes all the way to the bottom. Blue is your finish pass, but it already has a D in it since the top part, since it first feeds into the top by Z0. So that will open our hole to 1 inch 062. The only problem here is that it takes 52 minutes, which is really slow. This is not a speed program. This is just meant to show you how to make a quick bolt pattern, how to drill it out, how to make a tool. If you don't have large tools that fit in your Cat 40 machine, use a smaller drill, helix it with a smaller end mill, standardized tools. That's pretty much it. I'd change the sequence in which they run. You can do that here in the tool library for this job. Setup one, and we'll change that to 4. Press accept. We'll change the 1/2 inch end mill to 3. If it catches up, press accept. Okay. Close. Now our tool's in the proper sequence and tool numbers. And that's it. Let's run a simulation just to be sure we like it before we send it to an operator. Center drill, PEX cycle, G83, sorry. Helixing in. Let's slow that down so you can see the helix real quick. Oh yeah. So that's a good tool path for making a larger hole with it, using smaller tools. And that goes all the way around, and then we will see our chamfer tool comes around, and we didn't have to reselect anything because we had the geometry selected on that chamfer tool, and it puts a 20 thousandths chamfer. That is it. I hope you enjoyed this video. Hope it was useful. Like and subscribe.